So today I want to talk about my love-hate relationship with testing. I've been a developer for almost 20 years now, so like many relationships, this one has evolved quite a bit over the years. I spent a majority of my career working on back-end development, mainly with Java and Spring. Within the Java community, testing was a really big deal. It was expected that you would write tests for all of your code. But then we were working on the back end. Our code was primarily business logic and database integration. And because we're using technologies like Spring and Hibernate, our code was pretty easy to test. We used dependency injection, and we configured our classes in XML files so we could swap out implementations for testing. It was easy to mock our dependencies on the database and on other frameworks. And because we didn't have any UI, we didn't have to worry about UI testing. This is what I'll call my honeymoon phase with testing. It was easy and effortless. Then about 5 years ago, I decided I needed a change, and I moved into mobile development. I tried both iOS and Android, but I fell in love with the iOS ecosystem. Coming from my back-end background, UI development was this shiny new toy that was really mysterious and intriguing. For the first time, I could actually see what my code looked like because I finally had a visual interface. Now I could write an entire application all by myself without relying on a front-end team to make a project fully functional. However, I quickly noticed that the iOS developers on my team weren't as enthusiastic as I was about testing. At the time, I was working at a custom software development shop, and testing wasn't something that we could easily sell. Clients didn't want to pay for it, and they especially didn't want even more code to maintain. XC test support in Xcode wasn't great at that time. And when it comes to testing in iOS, we have things like UIKit and the MVC architecture pattern that often hold us back from being able to thoroughly test our apps. iOS code can be pretty tightly coupled. Everything connects to everything else. It makes testing so much harder. Even though I was a full-fledged supporter of testing in Java, I pretty much gave up on testing in iOS. My relationship with testing wasn't going well. We had drifted apart. Then in 2015, I attended WWDC for the first time. While I was there, they announced support for UI testing in Xcode. I was so excited. I could actually test my UI code now. Maybe this would be the thing that would generate more support for testing in the iOS community. I was so excited to try it out, but when I finally did, I have to admit I was pretty disappointed. It was really buggy, and there just wasn't much functionality available. I couldn't figure out how I would even use it within a real app with the complex code bases I was used to working in. So I gave up on testing again. Until now, I've decided that I need to rekindle my relationship with testing. So why now? I'm working on a product called TRELLO. If you haven't heard of it, it's a visual collaboration tool that helps you organize your life. Work, school, weddings, vacations, community groups, you name it. And now that I'm working on a product and not consulting, I have to maintain it. And testing suddenly became very important again. It's an easy sell because I'm selling it to myself to make my job as a developer easier. Since I started at TRELLO last year, I've been meaning to take another look at UI testing to see if it could finally provide the value I was looking for. It's been a few years since it was announced, so things have changed. I wanted to find out, what can XC UI test actually do? What are other teams or people doing for UI testing? Most importantly, what should TRELLO be doing? And how can our testing process be improved? So those are all the questions that I set to find out for my team and for this talk. Before we start talking about testing strategies, let's define our goal. Why are we testing? My goal is to have a high degree of confidence that our app is working as expected. However, we don't have an infinite amount of time to test, so we need to balance the amount of testing we do with the value it provides. If we're constantly testing, we don't have the time or money to write new features. In order to determine what Trello should be doing for testing, let's review our current testing strategy to see where the gaps are. There are many levels of testing we go through on a daily basis to test the code we write. I'll point out which steps are automated, but currently most of these steps are manual. The first step is the simplest one. We build our project in Xcode and make sure it compiles. Technically, this is an automated task that Xcode handles for us. Now we want to make sure our code will actually run in a simulator or device, and if so, that it does what we expect it to. As iOS developers, I'm sure we're probably all very familiar with these first two steps. We use XCTest for unit testing within our app. We currently have 834 unit tests, which cover functionality like JSON parsing, formatting time zones, all kinds of business logic. These tests are run every time we merge code into our Git repo. We try to write tests that cover most of the new code we write, but it doesn't always happen. We could be doing more here, but we've got pretty decent coverage so far, and these tests are automated. Integration testing is where we test each flow or use case within our app. We make sure all the individual pieces work together to produce the right experience. We ensure our navigation is correct, our screens look as designed, error handling works as expected. Unfortunately, most of this testing is currently a manual process, but we do have 2 instances of automated integration testing that have been built out. Unfortunately, neither of these tests were working when I started this talk. We had done some refactoring of some of our cardback logic, and they were both commented out. But I was able to fix them while I was working on this talk. So, progress. Here is a screen recording of our UI test. It starts off with some environment setup. After logging into our test account, we navigate to the settings screen and make sure that our GUI testing toggle is set. This is a field that's only displayed when we're testing or building locally. It doesn't do much, it just turns off some hints that we have on our onboarding screens. But it's available if we need to override additional functionality later on. Our UI test is a very simple smoke test that runs through some key functionality in our app, just to make sure it works. It's one long test, but it contains a lot of functionality. We create a Trello board, we create a couple lists with some cards, we move the cards around, we open a couple cards, we edit their checklists, descriptions, labels, due dates. Our tests currently don't use any mocks, so real data is being pulled in from the server. This slows down our tests, so that's something we could improve in the future. We can run the UI tests from Xcode manually, or we can use Blue Pill to locally test multiple simulators at once. The other form of integration testing we use is snapshot testing in Fastlane. We test that a few key UI elements like checklists appear as expected. We also use it to generate screenshots for App Store submissions in our supported languages. After our developers have tested their code thoroughly, they submit a pull request. Every developer on our team reviews their PR in Bitbucket and must approve it before it gets merged in our code base. Here we help each other catch potential flaws or edge cases that the developer may have missed. All the unit tests must pass on the server before the code can be merged. Stephanie is our tester on the iOS team. After a PR has been merged, she tests each one of them manually on all of our supported devices to make sure that the functionality looks correct. She breaks all the things, and she's very good at it. Everyone should have a Stephanie on their team. We have 2 groups of beta testers for each release. Our internal testers consists of a smaller group of employees that we selected to provide us with immediate feedback. This includes our head of product, our designers, product managers, and other key employees who want to weigh in on the app before it gets released externally. We also have an external beta testing group that goes up to a much wider set of users. Anyone at Atlassian who wants to be involved can sign up, but we also open it up to external users as well. Once we have a release that we feel confident in, all the developers on our team spend a day or two going through our smoke testing checklist on each of our devices. Every developer has at least one iPhone and one iPad, if not more, that we use for testing. Our current UI test is supposed to automate this phase of our testing cycle, but as it is, it only covers a very small portion of the amount of testing we have to do manually. There is definitely room for improvement here. Once we all agree that the app is good to go, we submit the release to the App Store. This is the scariest step of testing, making our app available to all of our users. But it is basically another step of testing with the highest consequences. We really don't want to find bugs here. We want to find them as early in the process as possible. Trello is very lucky in that we have a lot of users and people who consider themselves fans, which is not something I've ever experienced before working on a product. But because we have so many users, we get a lot of feedback, especially when we mess up. The problem is that we don't get to choose how we receive that feedback. The users do. So they may send in support tickets to our help desk, which gives us a lot of helpful information for troubleshooting. Or they may just give us a 1-star review on the App Store and give up on the app completely. So we keep an eye on analytics and crash reports to see if we've introduced any critical issues. We try to make it as easy as possible for our users to reach out. So we have a Slack account for people to connect with our support team and even with some of our developers. Our growth at Trello has been very viral, so making sure our users stay happy is very important to us. Even though we have a fairly robust testing strategy, unit tests are currently the only step that's heavily automated. Our integration and release testing steps are prime candidates for automation through UI testing. Our developers spend quite a bit of time running through manual smoke tests when they could be using that time to work on features or bug fixes. So knowing now where we can improve our process, I began researching the functionality available within Xcode's UI testing. There are other frameworks out there besides this one, like KIF and Earl Grey, but I'm going to focus on the functionality available within Xcode because it fit best for us. We like that we can write our tests in Objective-C and Swift. We can use recording to help us write our tests. We can run our UI tests along with our unit tests and see consolidated code coverage in Xcode, and it works well with our CI build process. During my investigation, I read or watched about every tutorial I could find on Xcode's UI testing. For the most part, these tutorials covered really basic functionality. You can test a button tap, you can test a segue, you can test error handling. If you haven't played around with UI testing in Xcode, I'd suggest starting with some of those tutorials as well as the WWDC video from 2015. I'm not going to cover the ins and outs of how you use it today. Instead, I want to talk on some of the topics that these tutorials didn't cover. I personally wanted a deeper understanding of the functionality available beyond those basics, so I started researching some of the things that I wasn't seeing in those tutorials. Watch seems like a prime candidate for UI testing, since it's not a product that we end up testing a lot, and it's not currently covered in any of our smoke tests. Unfortunately, Apple does not provide the ability to UI test Watch OS. I did find a blog post from one developer about hacking Watch OS for UI testing, but that seems pretty risky. There is a way to interact with SIRI in UI testing. You can use the SIRI service on XC UI device to pass in your voice command as a string. However, there are a few caveats I found while testing. The first is that recording does not work with SIRI. And the second is that while SIRI service understood my intent, the command that I passed in, it always prompted me to open the app with a button. And I had to manually tap that button in order to proceed with the test. I tried all of the voice commands I could think of to try and get around this, but it had to be manually tapped. So if anyone has done anything with this and knows the way around it, please come talk to me. You can't test animations in Xcode, but you can disable some view animations to speed up your tests, which I would recommend doing. You can access alerts just like any of the other UI elements. You can also skip through system alerts using a UI interruption monitor, which is helpful for getting past those push notification or location setting prompts after you're installing a new app. Translations were one of the first ideas I had for UI testing, but the lack of support for this one kind of surprised me. It can actually be quite difficult to test the string value of labels. For example, let's say I wanted to make sure that a label with the value of board was translated correctly across all languages. If that label has an accessibility identifier, or if it's coming from a storyboard, you may not be able to access a string value anymore. Translations are probably better tested through other methods. So what did I learn? Throughout my investigation, I ran into quite a few problems with Xcode's UI testing implementation. The main thing that I learned is that it's really flaky. My tests would fail about 20% of the time for what appeared to be no reason, because they would work just fine the next time I ran them. This is a complaint that I found really common online as well. Because of that, I wouldn't recommend including UI tests in your continuous integration builds. Run them as a separate nightly process or manually trigger them when you want to do smoke and regression tests. Apple historically hasn't put a lot of investment into testing support, but UI testing has been improving steadily with every release. I'm optimistic the tools will eventually be stable enough to include in our CI builds. I learned quite a bit about testing in Xcode during my research, but before making a determination about what TRELLO should do to improve our test process, I wanted to do a little more research to find out what other teams are currently doing for UI testing. I sent out some tweets, I asked for opinions in Slacks, I DM'd some friends and coworkers, and I asked them all 4 questions. Do you currently do UI testing? Which tools or frameworks do you use? What type of functionality are you testing? And who writes and or maintains your UI tests? Out of the 11 teams that responded, 7 were currently doing some form of UI testing, which was actually higher than I thought. 6 were using Xcode for UI testing, and 1 went from KIF to Earl Grey. 2 were also using Fastlane automatic screenshots, 1 in conjunction with XCUI test. Almost everyone said they used UI testing for testing core functionality and for smoke testing, but a couple other people also said they used it for navigation and analytics. Most UI tests were written by developers and maintained by either development and or QA. 2 mentioned that they had mocked out their network layer to help speed up their tests. There is one other approach that I want to talk about before moving on. About a month ago, a coworker started talking about the KICKSTARTER app and some of the cool stuff they've been doing with testing in playgrounds. Their app is open source, so you can go check it out. They don't actually use UI testing in their app because they've been able to move most of that functionality into their unit tests. Their app reminds me a lot of my Java days. They're using MVVM architecture, which abstracts the UI code away from the business logic. They use dependency injection, so their code is easier to test. They pass in environment properties, which allows them to have a lot more control over their tests. They use playgrounds to test each of their views separately within their app. It's a pretty neat way to test since they can dynamically change environment properties. They can preview their screens in every language from within the playground. There are a couple drawbacks to their approach, though. Everything relies on a very specific uniform app architecture, and if yours doesn't fit, you have a lot of refactoring to do. This kind of refactoring would likely be far too large a task for Trello to take on. While testing their approach with my own sample app, I ran into a lot of issues with playgrounds. The UI would freeze up or error out for no reason, and I constantly had to restart Xcode. Playgrounds, like UI testing, are still kind of flaky. Maybe Kickstarter has some magic to get playgrounds to behave, but it was pretty frustrating for me, and I was only working on a small sample app. So after all my research, it was finally time to come up with my plan. While I really like the Kickstarter approach to testing, we can't fully implement it. Our architecture is kind of a hodgepodge of ideas, old and new, which is probably typical for startups that scaled quickly. We just don't have that uniform app architecture. We still have a lot of Objective-C left in the app, while everything new is written in Swift, but no matter what, we still have this tech debt that we have to deal with. A large-scale refactor would be costly and likely wouldn't provide enough value to justify the expense. With that in mind, I came up with some achievable goals for us to improve our testing process. One is to create automated smoke tests that would relieve our developers of the valuable time spent before every release and would generate more confidence in our test process. We could attempt to mock our API to speed up our tests and reduce opportunities for failures. This might require a little more refactoring for us due to our legacy code-based constraints, but it might be worth a try. We could further enhance our snapshot testing to provide better coverage of our visual components. After all this research, I've now got a plan to take back to my team and some UI tests that are finally working again, and now I can focus on making our tests even better. If you have any questions on testing or tips and tricks you'd like to share, I'd love to chat. Thank you.